Welcome to the talk this afternoon. I think everybody a little tired now. So I'm not Weiqing, which is working with us, and she has some visa issue, and she can't come here. So I just come here to present our group works, Apache Spark, Apache HBase connectors. This talk will introduce how we can use Spark to read and write data from HBase efficiently, do some OLAP query processings. I think everybody here is already know HBase and Spark, right? Nobody, yeah, I hope everybody have heard about HBase and Spark, right? And HBase, I think, is very popular and very efficient for data insert, right? And then, but sometimes this HBase is a lot efficient for data processing. Means that if you want to have extensive OLAP query and then do some analyze, traditionally, people use Phoenix, right? I think there are some people use Phoenix there because Phoenix is pretty easy to use and friendly, the interface is friendly. But if you have very complex job, right? If you want to do some table join, do some other things, you need to use Spark, okay? It's what we motivated this work today. Apache HBase Connector. We use Spark to query and process data in the HBase. Okay, this work is worked from Weiqing. Weiqing is working on the HuntWorks for 2 years. She graduated from CMU and working in the Spark Curl, Spark SQL, and Spark Apache HBase in HuntWorks. I'm Minjie. I'm from the HuntWorks as well. I work on the Spark SQL and the Spark Machine Learning Library. And this morning I gave other talk about how we can do the matrix operation over the Spark. So yeah, we're also a software engineer and HuntWorks. I also very thanks to other Spark HBase connector SH3 contributors because we get maybe 15 and 60 issues. Yeah, we had lots of issues in our code, and everybody posts the issues there and fix there. Thanks everybody. Okay, this is our agenda. Okay, first we introduce our motivation, overview, architecture and implementation details, and how we can use it. So first, I think everybody have heard that, okay? The HBase is popular, Spark is popular, okay? How to build a connection between HBase and Spark? There are lots of approaches there. For example, in the HBase upstream, they all also have some like chunk or some approach to support the data processing over to use Spark RDD to get data from HBase and do some processings. However, by that approach, you can say that's based on RDD. RDD is not very good for the OLAP processing and not for end user to do some SQL, right? If you're not familiar with RDDs, it's not easy to use. Okay, and also we have heard that lots of HBase connectors as well, like Huawei, they have their own repo to do some read the data from HBase uses Spark engine. But however, what is their implementation? They exchange the internal of Spark SQL extensively. It means that if you don't have the source code of the Huawei, you can't use it. However, our system or our SHC is only extend from the data source API for Spark. It means that different version of Spark, like Spark 2, Spark 2.1 and Spark 2.2 is only small modification in the package itself, not the Spark internal itself, and then we can use it. This is very efficient and this helps user to use it very friendly, right? And more important thing that you can see, we want to use the Spark SQL, right, to do some OLAP processing. It means that we want to do some optimization of the Spark SQL to push down into the HBase. It means, for example, everybody heard about the Spark SQL is very good at like filter pushdown, right? Column pruning, and projection pushdown, right? This kind of optimization is already applied in the Spark SQL. How we can apply this kind of optimization into the HBase? So we want to extend the Spark SQL to support this kind of function. This is SHC. In our system, so it's very summary. It's very good and to read and write from HBase, and also use the Spark SQL's optimization technique there to some optimization. I will introduce more details later. Okay, this overview is like first, okay. I think everybody heard about that. HBase is a key value pairs, right? Every data is a key and value, right? But traditionally, if you for OLAP query processing, you think data as a table means that you need to have mapping between the key value data and the table, relation table. So we define some catalog, okay, to map the HBase data and the relation table. We call this a catalog mapping. This is the first step. And then after this mapping, we provide, okay, you view the HBase data as a table and run Spark SQL queries there. Therefore, this works is very good with Spark SQL and DataFrame APIs. And we have some lots of performance improving, like partition pruning, data locality, column pruning, predict pushdown. And then we can use Spark unhandle filter APIs or catch HBase connections, blah, blah, some things. Okay, so first, I introduce interface, something, okay? First, when you write data into HBase or read data HBase, you need to have data type, right? Because the HBase, they only have beta array, right? Everybody hear about it, beta array, only beta array. I don't understand Avro, Felix, or other data types, right? So we first provide different data encoding and decoding approach. Means that the end user, you can write data in Avro format, for example, Avro format into HBase, and read the data from HBase in Avro format. Similarly, we support Phoenix. Because I know that lots of people use Phoenix right now, okay, because Phoenix is very easy to use. So we can provide this approach to read data from the data that writes by Phoenix. And then we can read data, and we can understand, okay, this is Phoenix data, and we're decoding the data from Phoenix to the Spark SQL, and then do some execution there. We also provide some approach, like the user, okay, end user, we have some personalized data encoding or decoding approach. And then you can plug in your data encoder or decoder there, and run exist HBase tables. So the other thing we do is very interesting. We support the composite keys. It means that one key have other key, blah, blah, some things. And then we provide this kind of function, and you can use, the end user can do the composite key to insert data into the HBase. Okay, this agriculture, I think, is very basic and very fundamental. Okay, because why? Because we want try to minimize the system update, right? It means that we still follow the architecture of the Spark and HBase. That means that the Spark is follow like a master and driver. Master is a driver, right? And the slaver is executors. So what I want to do is we want to do the data collecting. This is the first part is the Spark. This later part is HBase. And then we want executor and HBase region server is co-located, right? It means that the data locality can be guaranteed. Means that when you want data from one certain region servers, this executor don't need to go to other region server to get data, right? This is a very important thing, and this can guarantee our performance much better than other systems and things. Okay. And when you have query, for example, okay, first the query is coming, the driver gets a query, right? This is like a Spark SQL first, right? You get a query, for example, select something from one table, blah, blah, some things, okay? The driver can translate the SQL query to ask the catalyst to understand which kind of partition, which kind of region server you need to get. And then the executor can get data from corresponding region servers. For example, you get the end and read start and end point from region servers. You can prune some partition as well. Okay, this task, start a task in each executor, and the executor to get data from region servers, right? And we provide the scans bucket gets. It means that we can groupize multiple gets together to get data from HBase more efficiently. Okay, the second thing, like when we do some searching, okay, for example, you have filters. We want to do some filter pushdowns. Traditionally, you can think the other approach, other systems read data from HBase, all data from HBase, and then translate the data into the Spark internal data type and do some filters in there. You can see by this way, you have to read all data from HBase, right? On the other hand, our approach, we push the filter down into the HBase region servers. Means that when you get data from HBase, the filter is theirs, and then the filter, because we do lots of binary code executions or the bit arrays native execution there. So it means that when the filter pushes down into the region servers, the HBase can read the data based on the filters. It means that data to the Spark kernel part is more or less, right? You can reduce the overhead memory usage from the Spark SQLs. Okay, and then we can prove that partition. Okay, for example, some partition is not related to the filter, not related to these conditions. Its partition can be proved, right? This is very important. You can say this is a very basic approach, but in our experiment, we found this approach achieve a lot of system performance enhancement. Okay, the other thing, like, yes, we data locality, move computation to the data. And RDD partition have the get partition RDDs and get partition, okay, from the HBase master load, right? And then we can get, okay, which region server we can scan. Okay, this is column pruning. And when you require columns, you can prune the column as well because HBase have the APIs, okay? Because we prove, because for example, you search the HBase, when you have the query in the Spark SQL, right? And the query only requires certain column of the HBase. And then because based on the catalyst can translate, okay, which column you want to get. And then we get this which column you want, and then we send this kind of information to HBase, and HBase can help us to prune lots of columns we don't need. You can see this kind of things like we translate SQL query into some as possible as we can to push down into base. But we can't push like join into HBase as well. We want to do some other very complex job into HBase. So we choose a certain kind of the push down approach there, like column pruning, predict push down, and some things. Okay. A scan block gets is like similar things. You have like this kind of condition, column bigger than X and column smaller than Y, and a scan and where column X for get. Okay, we can bucket this together to save the cost. Okay, this is the general frameworks. So we want to introduce some basic using API for us to learn. Okay, let's open this. Okay, here we provide how we can use the Spark HBase connector here. For example, we provide a different example here. Okay, sorry. Okay, just show very simple case. I think this example is very interesting to use because we want to join two tables or data from two HBase cluster. Okay, one data. Oh, you can see. Okay. I think. Okay. Yeah. Okay. This is the example we want to show here because go to the repo previous levels. Okay, there are multiple examples here. For example, how we can get data from the Avro data type, how can we define the catalog, how can support a composite key, how we can define the personal data coder and encoders, data type, HBase source, and a join table from two clusters. For example, you have two HBase clusters there. You want to do some join before two clusters. For example, one table from one cluster, one other table from other cluster. And you want to use Spark SQL to get data from two HBase and to join them together. We provided this kind of functions there. Okay, this is an example. I think If people interested, you can look at the code more details here. But one interesting thing and our implementation here is like when you get data from multiple HBase cluster, you need to consider the security, right? It means that we need to have some token management to get data from multiple HBase cluster. This is a lot while provided in previous works. It means that okay, you have the token to to access the multiple HBase clusters. Our system can help you. You don't need to reinitialize token every time and help you to get data from multiple HBase data. Okay, this is our example. For example, just show belong. For example, we get two data from one data from one HBase cluster and other data from other HBase cluster. We do some filters on here. One use the DataFrame API, right, and other tables as well. And then we join two tables together. You can see all the data is from HBase, right? This is HBase 1 and HBase 2. Before we get data, we need to do some catalog mappings. Okay, I will show what's the catalog mapping here. Let's go back. I will show some more usage here. Okay, this is the usage we want to introduce today as well. First, we need to have some catalog. As we mentioned before, we need to have some mapping between the key value pair data to the relation data, right? Because HBase don't have a table, right? So it means that we need to define this catalog mapping to get data from HBase. So what's mean here is first, the table's namespace default is like a database, right, in the HBase. And name, it means that the table names like a Felix table. And data coder is a Felix type. And version, you can see in your version as well. And root key, we need to define root key like a key for HBase table, right? And then you define your column 1, like column 2, 3, 4, 5 to 8. And you define the type, right? By this way, you can define what's the mapping between the HBase data to SQL table. Based on the catalog, okay, you can, for example, we generate one data from HBase, from Spark SQL, right? It's a raw data. And then we parallelize the data into RDDs. And then we change this RDD to DataFrame. And white options mean we use previously defined catalog. And then new table means how many region server we use, like for example 5. And the format is data source HBase API, and we call save. By this way, we can write this kind of data into the HBase. Okay, this is write data into HBase, right? Similarly, we use this load data, similar approach, we can read the data from HBase as well. For example, because we already defined the catalog before, and we can use the predefined catalog, read data from HBase. And then, based on this function, we can read data from HBase as well. Okay, but after data read from HBase, we can do some operation based on your requirement. For example, the filter some things and select some things. Okay, you also can do some SQL operation over the data from HBase as well. For example, you can register this data frame table as a view, and then you can use Spark SQL to correct the data from here. Okay, this is the other thing, like we join data from different table. Like for example, you have some data from Hive, and you also have data from HBase. You want maybe join data from the HBase and Hive together, right? This is multiple scenarios. It means that our system is just it's just a part of a Spark SQL ecosystem. It means that Spark SQL can read data from different data sources like JSONs, Hive, other things, and we provide other kind of data source, right? HBase, and then you can use Spark SQL to do what you want. It's very efficient to use, and when our performance study, we found our approach. Our system shows much better performance than the Spark SQL without our optimizations. Okay, this is usage. I think we have a demo before. So if you are interested, you can go to our demo on the videos on the YouTube. Okay, this is our public repos. I think everybody, if you want to use Spark SHC, you can go to there to download the code. I think it's very easy to use. And then we would thank everybody here and other contributor in the Spark and HBase community. They help us to improve the performance issues, get lots of feedback from things. And our customer have lots of customers use it now. Yeah, just here. Some people asking me what issue here is. Sorry, I don't get some details there. And then you can, if you have some issues there, you can post your issue in the Avro GitHub repos, and we can send us feedback and get some other PR to fix this issue as well. Yeah, that's all. Yeah.
Thank you. So we have 2 mics, so please come forward if you have any questions.
We're currently using Ranger to protect HBase. Do you know if with implement this connector, will Ranger support that?
Okay, your question like you have Ranger to manage the security for the HBase data, right? And then you want to use the SHC to also support the Ranger. Actually, we don't support this right now. Yeah, but we have other project we call the Spark AOAP. It provides the access control to the table on the column and row levels, and you can think that table can be from HBase or can be other things. Yeah.
LLAP.
Yeah, Spark AOAP. Yeah.
I worked with that with Hive. I haven't tried it on HBase yet.
Yeah. I think that one, you also can think, use that one to manage data from HBase because data also can be registered from HBase, right?
Okay, thank you.
Yeah.
Can you tell us which version that it's applicable for, which HBase version and which Spark version we can use it?
Okay, so actually for Spark part, we provide the 1.6, 2.1, 2.2, and the HBase version, I forget it, but we test the most recent HBase versions can work, and we do a lot of extensive experiment studies there. Yeah.
Yeah, I'm looking more for the older versions actually, like for HBase 1.0. But okay.
Yeah.
So for the writing, so that's using then HBase bulk load.
Sorry?
Are you using then the HBase bulk loads when you're writing the data frames to HBase?
Yes.
So it's not like a regular put that you
Yeah,
write?
No. Yeah, that's what we really do some performance improvement, right? Because you do white data, you needed to try our best to use the best API in the HBase to write data there. Similar for the get data as well. Yeah.
Okay. Yeah. Thank you.
Yeah.
Any other questions? All right, well, thank you again.
Thank you, everybody. Yeah, have a good day.